If life on Earth had taken 10% longer to develop, it might not exist at all. Nearly a lifetime ago, we bid farewell to Voyager 1, sending it on a one-way mission to uncover the mysteries of our solar system and beyond. Like a tireless pioneer, Voyager 1 has continued to transmit extraordinary data back to Earth, unveiling astonishing discoveries about the universe and exploring uncharted territories we never knew existed. Now, Voyager 1 has surpassed all expectations, delivering a groundbreaking revelation that has left scientists astonished. The spacecraft's latest findings are poised to reshape our understanding of the universe. Could it be true that Voyager 1 has crossed into interstellar space? Join us on this cosmic journey as we explore the incredible events that have unfolded. Interstellar space has never seen anything quite like Voyager 1. This marvel of engineering has ventured into regions of the universe that continue to astonish even the most seasoned scientists. For over 45 years, Voyager 1 has defied the odds, providing discoveries far beyond its intended lifespan. Initially expected to operate for just a few years, the spacecraft has not only outlived its design but also traveled billions of miles from its launch pad, rewriting the rules of space exploration. Thanks to Voyager 1, scientists have been forced to reconsider long-held beliefs and adopt new models of interstellar exploration. The spacecraft has amazed everyone with its ability to send data back to Earth despite its immense distance and outdated technology. And now, it has delivered a revelation so significant that researchers haven't stopped discussing it since they deciphered its latest message. The story of Voyager 1 begins in 1965, when space exploration was still in its infancy. NASA scientist Gary Flandreau, working at the Jet Propulsion Laboratory, discovered a rare planetary alignment among Jupiter, Saturn, Uranus, and Neptune, a phenomenon that occurs only once every 176 years. This alignment allowed a spacecraft to use the gravitational pull of each planet to gain speed, significantly shortening the journey time from Earth to Neptune. Realizing the unique opportunity, NASA acted swiftly, launching twin spacecraft, Voyager 1 and Voyager 2, within 15 days of each other in 1977. Their mission: to explore the outer planets and send back data. Although researchers were optimistic about the discoveries the spacecraft might uncover, nothing could have prepared them for the groundbreaking findings that lay ahead. The Voyager twins exceeded all expectations, providing unprecedented close-up views of Jupiter and Saturn. They revealed these planets to be far more dynamic and complex than previously imagined, uncovering active volcanoes and dazzling ice fields that reshaped our understanding of these distant giants. What's more, Voyager 1 continued its journey, venturing into interstellar space, becoming the first human-made object to do so. Despite its vast distance from Earth, the spacecraft has remained operational, consistently transmitting valuable data back to NASA. Its resilience and longevity have left scientists in awe, solidifying its place as the oldest and farthest-traveled spacecraft in history. The Voyager mission's legacy is nothing short of extraordinary. Initially designed for a 4-year mission, the spacecraft has continued to deliver insights for decades, challenging our perceptions of the cosmos. From revealing the breathtaking landscapes of Jupiter and Saturn to pushing the boundaries of interstellar exploration, Voyager 1 has transformed the way we view our universe. As Voyager 1 ventures further into the unknown, it reminds us of humanity's relentless curiosity and the limitless possibilities of exploration. With each transmission, it brings us closer to unlocking the secrets of the cosmos, proving that even the most ambitious dreams can become reality. The vast and mysterious region of interstellar space, a domain where comet-like objects are bound together by the sun's gravitational pull, has long been a subject of fascination. This area, stretching far toward the closest stars, is one of the intriguing regions that the Voyager spacecraft has been investigating, gradually unveiling secrets hidden deep within the cosmos. One such significant point of interest for Voyager 1 was its approach to interstellar space, where the solar wind's characteristics give way to a more open region at the outskirts of our solar system. Before entering this captivating area, Voyager had to pass through the heliopause, the boundary separating our solar system from interstellar space. When Voyager crossed this line, astronomers were elated, and the scientific community eagerly anticipated the groundbreaking discoveries that would emerge from this monumental event. However, what scientists found was surprising and perplexing. The initial estimates of the distance to the heliopause before Voyager's arrival were inconsistent, with expectations placing it around 50 astronomical units. This led to an extension of the mission's funding. Yet, when Voyager passed the milestone, scientists were puzzled. Despite the anticipation of finding certain indicators, such as a sudden increase in cosmic rays and high-energy particles from supernovae and other cosmic disasters, no significant changes were observed. One of the expected signs of crossing into interstellar space was the increase in cosmic radiation, as the heliosphere's magnetic field typically shields the inner solar system from much of this radiation. However, Voyager detected no such increase. Instead, the spacecraft continued to report that there were no noticeable changes in the surrounding magnetic field, contrary to what scientists had predicted. This led to a wave of confusion, as researchers had expected the transition from the Sun's magnetic field to that of the interstellar medium to be accompanied by a distinct shift in the magnetic field's direction. Voyager's data further confirmed an increase in plasma density, which was anticipated, but the lack of any indication of a change in magnetic field direction left scientists scratching their heads. They had expected a shift from the Sun's influence to the interstellar medium, which is affected by nearby stars. Yet, this was not observed, and the spacecraft remained cloaked in a veil of mystery. The breakthrough came on August 25, 2012, when Voyager 1 crossed the heliopause and sent back valuable data to Earth. This data confirmed the expected increase in plasma density, but still, no changes in the magnetic field direction were detected, contradicting theoretical models. It took some time for scientists to fully process this surprising result. While researchers had speculated that the heliopause might be farther than expected, possibly more than 120 astronomical units, Voyager's readings suggested otherwise. In November 2018, the excitement continued as Voyager 2 embarked on its own journey into interstellar space. Its approach to the heliopause, at a distance of around 120 astronomical units, mirrored Voyager 1's arrival 6 years earlier. The scientific community hoped that Voyager 2 would confirm similar findings, but once again, the spacecraft detected no change in the magnetic field, contrary to expectations. This only deepened the mystery, as the spacecraft's observations defied the predictions made by existing models. This unexpected behavior led to further debates among astronomers. Some believed that Voyager 2 had not yet crossed into true interstellar space, while others argued that it had already done so. The presence of cosmic rays and increased plasma density led some to conclude that the spacecraft had indeed entered interstellar space, even without the expected magnetic field shift. The mystery deepens as the Voyager spacecraft continue their journey through the cosmos, operating on decades-old technology with minimal software updates. Their ongoing mission, potentially extending to 2030, promises even more remarkable discoveries as they approach Proxima c, possibly unlocking even more secrets of the universe. Who could have imagined that a rocket, resembling a one-of-a-kind Volkswagen Beetle, would venture into an unknown region and return with revelations that were beyond our wildest expectations? Much like a brave explorer entering the heart of a dense forest, Voyager 2 did the unexpected by becoming the first spacecraft to get so close to Uranus in 1986. It then continued on its remarkable journey, passing Neptune in 1989. To this day, Voyager 2 holds the distinction of being the only spacecraft to travel such vast distances, uncovering monumental discoveries about these two distant worlds. Without Voyager 2's bold journey, we would still be in the dark about our understanding of these far-off planets. The spacecraft's incredible mission has now taken it more than 14 billion miles away from Earth. In contrast, Voyager 1 faced its own challenges early on in its journey, requiring help to get underway. This started with a gravity assist from Venus, a maneuver never attempted before, to aid the spacecraft's path toward Mercury. Voyager's mission was filled with record-breaking achievements, setting new milestones every day as it journeyed through the mysteries of interstellar space. Though the story sounds thrilling, it was by no means an easy ride for these explorers. While their journey seems straightforward now, the tests they endured were nothing short of extraordinary. One of the earliest challenges was making the essential maneuver to Mercury, while the initial leg of their journey to Jupiter involved difficulties, as the spacecraft ventured far beyond Mercury's orbit. Their route took them through the asteroid belt, where they faced a high-risk path that threatened to derail their progress. But despite the dangers, they persisted, crossing the belt and continuing their groundbreaking exploration of the solar system. Even after overcoming the asteroid belt, challenges persisted for the spacecraft. It faced difficulties as it traveled through space, requiring the craft's computer systems to rely on onboard systems due to limited memory. Just 69 kilobytes, roughly equivalent to a fraction of a modern smartphone's storage. The spacecraft's instruments stored data on recorders before sending it back to Earth via a modest 23-watt transmitter, no stronger than a refrigerator light. The spacecraft also featured a 12-foot wide dish antenna to communicate at light speed, sending and receiving messages across vast distances. The immense distance between Voyager and Earth created further hurdles, as it became increasingly difficult to maintain a connection. Signals from Voyager 2 took more than 18 hours to reach Earth, making communication a complex process, especially as interference from Earth's radios, TVs, and cell phones added to the challenge. Yet, despite these obstacles, both Voyager 1 and 2 have triumphantly continued their missions, sending back groundbreaking data that has stunned scientists. These discoveries have drastically changed our understanding of the universe, overturning long-held beliefs and presenting a new perspective on the cosmos. One of the most significant moments in this journey occurred when Voyager entered the Oort cloud, an exciting milestone in this extraordinary interstellar voyage.